Well, hello and welcome back to another video blog. Just know that it's been a while since I've posted one, but I've actually had the pleasure of working with some of my teachers the last few weeks, and more recently, some teachers in fourth grade had some questions, very valid questions actually, and led to very meaningful discussions and very powerful practices in the classroom centered around the concept of compatible numbers and division in particular. And I say that it's valid because compatible numbers in general has really been a new concept, both for the students and more predominantly for the teachers in teaching it, mainly because we've really been focused on the concept of using rounding to estimate, not necessarily compatible numbers to estimate. So I want to spend a couple of minutes just kind of sharing with you some strategies on how you can share compatible numbers with your students. So let's talk about, for example, in fourth grade, the standard is to divide up to 4-digit by 1-digit. So I'm going to use a 2-digit dividend and a 1-digit divisor. And we're going to talk about what is the difference between rounding and compatible numbers when estimating, but also how do I use compatible numbers and what strategy do I use with my students to help them understand that concept. So just to kind of scaffold, rounding, obviously using a number line is part of the new TEKS. If we look at this problem here, 67, our dividend is close, maybe not that close, but it's rather close to 70. And we could say then that I want to estimate the quotient for 70 divided by 9. Well, the purpose of estimating, we want to help the students understand, is to get my answer quickly using mental math. And I really can't use mental math to divide 70 by 9. So rounding is not going to be the best idea here, or at least rounding to the tens place is not going to be the best. But even if I look at where 67 falls in relation to the hundreds place, is closer to 100. So I could still say 100 divided by 9. That I want to quickly estimate with my answer, and still that's not very friendly to work with. By friendly meaning I can't really use mental math to do it. So when we're talking about the word compatible, what we're talking about is numbers that are friendly, that help us to do mental math in a very quick way. So when we skip to the idea of compatible numbers, now that's not to say that we can't use rounding for that purpose, but that rounding is not the best technique that we want to use. So we're going to look at how we can use compatible numbers. So I'm going to slide this off a little bit here. And what we're going to do is we're going to ask the students to look at our divisor in order to find some numbers that I can use mentally or use mental math for, and some numbers that are compatible with the number 9. I'm going to think about my 9 timetables, or my facts for the number 9, or what I would call my multiples for the number 9. So we have 9, 18, 27, 36, and so on. And I would actually have the students list those facts off to the side of their paper. And then we'll go over here and say, okay, so I want to figure out how many groups of 9 I can get out of 67, about how many groups, because we were estimating, but quickly in my head. So is the number 67 in my multiples for 9? No. But the number 63, which is close to 67 and is compatible with the number 9, it is in my multiples. So I'm going to say that instead of using 63, I'm going to estimate that my answer is going to be about 1, 2, 3, 4, 5, 6, 7 groups of 9 that I can get out of 67. About 7 groups of 9. Okay, not exactly, but about 7. We're just estimating. So this is my compatible number because it's compatible with the number 9, and it helps me to do mental math quickly. I'm not trying to get the direct answer, just trying to get an estimate. Okay, so let's look at a few more really quickly, and we're going to look at some numbers that deal with the concept of the standard saying up to 4-digit numbers. So I gave you a 2-digit dividend. We're going to look at a 3-digit dividend. Okay, so here we have the number 356, a 3-digit dividend divided by the divisor 6. And again, I can't really do a 3-digit by 1-digit in my head. In this case, I could use a number line and say that 356 rounds to about 350 divided by 6, but I still can't divide that in my head. Or 356 rounds to 400, and 400 divided by 6, really can't do that in my head. So I'm going to use compatible numbers. Compatible numbers is going to be a little bit easier for me in this context. So I'm going to think of my divisor, and the numbers that are compatible, or what we would say be multiples of the number 6. And I'm going to ask myself, is the number 3 in my compatible number list? No. Is the number 35 in my compatible number list? No. But the number 36 is close to the number 35. So 35 here with another digit in the ones place is close to the number 36. So I'm going to put another digit here in the ones place, a 0. And I'm going to say instead of 356, I'm going to use a compatible number 360 to help me divide or estimate how many groups of 6 I can make. Okay, I can do 36 divided by 6 in my head. I know that that quotient is going to be 6, and then I'm going to put my 0 on the end. So I'm going to estimate that 356 divided by 6 is about 60 groups of 6. Okay, again, not trying to get the correct exact answer rather, but an estimated answer, and this I was able to do in my head. Okay, let's do one more example with a 4-digit by 1-digit divisor. All right, and here's our final example, 4-digit dividend with a 1-digit divisor. So I'm going to ask myself, or we were going to train the students to ask themselves, can I do this in my head? Can I estimate an answer in my head to find my quotient? No, I can't. Could I round this number to possibly 5,000? We'll say 5,000. That's an easy rounding number. But I could, but I still can't do 5,000 divided by 7 in my head. I may want to change this to 4,800. And still, not really friendly numbers there. And I'm looking for something that's friendly. I also shared with teachers that compatible can mean close to, but really in its rare form, it just means numbers that are easier to work with, okay, using from a mental math standpoint. So I'm going to have my students list the multiples based on their divisor, 7, and then we're going to go and ask ourselves, do we see the number 4 in my list here? No, which means I cannot get 7 groups out of 4. But do I see the number 47 in my list here? I do not. However, I do see a number that is close to 47, and that's 49. So what I want to do then is change this 47 to a 49. And in place of this tens, I'm going to make a 0 here. And in place of this 5, I'm going to make a 0 here. So my answer then, my new problem actually is 4,900 or 4,900 divided by 7. Can I do that in my head? Absolutely. I've made this 49 into 4,900. And now I'm just talking about my basic facts. 49 divided by 7 is 7. And for the 2 place values, I filled in with zeros. I'm going to do that in my quotient as well. And so I'm saying that my estimated answer is about 700 groups of 7 is what I can get out of 4,785. Now, when I have the students actually do the math using whatever strategy they need, then this estimated answer helps them check their work and ask themselves, is my answer reasonable? If they get an answer that's like 646, then yes, my answer is reasonable. I probably did my math correctly because 646 is close to 700. So I hope that helps you guys with the 4th grade standard on rounding and using compatible numbers to estimate. This same concept is also used in addition and subtraction and multiplication. But like I said, my teachers, we really had some valid conversations about how it applies to division. So thank you for watching.